reaction. Listen attentively now. Have you started? Lead one. It's not a chemical reaction. And we also say rate of chemical reaction is also the same thing as chemical kinetics. From the word kinetics, it means movement, right? Movement of chemical reactants, like their motion. So now rate of chemical reactions. Now then, so we now divide it as well. Yeah, class, read it down. I'm revising last class. Call me, 080, my phone number. Just call me, tell me. He said the rate of chemical reaction, come. The rate of chemical reaction is number of moles of reactants. Now, this WhatsApp video. So now, the rate of chemical reaction is number of moles of reactants converted or product form per unit time. So I gave example of your food that you cook, your Maggi, your salt, your pepper, and the likes. So everything becomes food. So the rate at which it is done. Now, if you add that gas, if you increase the gas, that will be done very, very fast, right? So which means the temperature will be very, very high. So the number of mole of reactants, all those Maggi, salt, pepper, they are reactants. They are being converted. They have their particular amount, moles means amount. So it's the amount of reactant. So you can also say it's the amount of reactant converted or product form by unit time. If you don't remember what they call moles. Moles means what? Amount. So now the test was how quickly a chemical reaction what happens. In a chemical reaction, look at it now. Zinc plus chlorine and hydrochloric acid. What happened here? Hydrogen gas is libated, right? So now we call this libation of hydrogen gas effervescence. What did I say? What did I say? Effervescence. Some people need warm up. I'm coming. Effervescence. So now libation of this hydrogen gas is called what? Effervescence. Is the libation of the gas from a solution or libation of the gas from a chemical what? Reaction. So now hydrogen gas will be libated. Now, so I can make this hydrogen gas to be libated within a short time, and I can also make it to be libated within a longer time. So it depends on how I apply some things that will make it to be fast, and those that make it to be fast is called factors affecting rate of chemical reaction. But that's our target for today. So now look at it now. So we said we can measure the rate of chemical reaction by taking a given mass of zinc, adding excess hydrochloric acid to it, noting the time taken for all zinc to react. Now how will I know zinc has reacted? By libation of hydrogen gas from the equation I showed you now. So the reaction rate is given by what? Amount of zinc converted. I told you amount is also the same thing as mole. Amount of zinc converted over what? Time taken in seconds. So that's rate of chemical reaction formula. So now they also define it this way also, that is the speed at which the reactants are used up or products are what? Formed. You can also define it this way. If you don't remember the amount of what? Reactant converted or product formed per unit time. Am I completing now? So now and this graph is called what? Rate curve for chemical reaction. This curve, now look at it now. This the mass of zinc that is being used is equivalent to the time. As the mass of zinc is being used, time is also increasing. This line here shows, as this one, when you say a straight line graph like this, it means if the value in this side, y-axis, if it's increasing, this value also be increasing. Here now I can just draw if I draw a table for this, I'll put time, I'll put what? Mass of what? Product. Then my time, maybe 2 seconds, maybe I'm using 30. This will be gram, this will be seconds. Am I calculating now? So if this one is 4 seconds, that time is doubling, right? This also be 60. I get it now. The rate at which this is increasing is also equivalent to the rate at which you can see the time is doubling, the mass also it will be doubling. But at this curve part, the reaction is slow because the reaction is about to come to an end. At this curve part, if it is labeled, the reaction is what? Slow. Because the reaction is about to come to an end. This horizontal line here shows that the reaction has come to what? An end. They can label the diagram for you. I get you now. So this reaction has come to an end. The reaction is slow. The rate at which the product is formed and time taken is what? Is equivalent. They are increasing at constant rate. This one. So now, rate curve for a chemical reaction. We call it what? Rate curve for a what? A chemical what? Reaction. Now, if this is how to get a gradient for a curve. A gradient for a curve. This is how to get a gradient. This curve here, you draw a line. And that line is called tangent. And for you to get a gradient, you have to get a triangle. You have to draw a triangle. So you take the value that is there from the time and value of the mass that is there. Value of the time, value of the mass. Then you use your old formula, which is change in y over change in x. That's gradient formula. So look at what they say here. You might see it in your exam. A larger gradient in the rate curve shows option A. Shows the fast side of chemical reaction. Option B shows the what? The slow side of chemical reaction. Option D, neither none of the above. So what are you going to pick? A larger gradient shows a what? So from the word larger, something big. If something is fast, it's also good, right? Now smaller gradients indicate what? So now if something is small, I guess now it's so similar to what? Slower what? Gradient. Hello? Sit down. Let me come to South Jude to your attention. Let me come to South Jude. Wait. Sit down there. Now look at it now. Collision theory. Every reaction that takes place, they undergo this theory. For two things to mix together, they must collide. If they didn't collide, they will not be able to mix together. I get you now. Who can think of any reaction you tell me? Sherry, stop sleeping. Any reaction? That girl also stop sleeping. That girl, Aisha, stop sleeping. Any reaction? Give me any reaction. Okay, let's do your normal one. Garri and water. You cannot be able to drink garri, or your eba will not form if your water did not what mix with what? Garri, right? Your water will enter the garri. So now, it will wet it, right? Then after wetting it, will break the bond. The garri will be soft. I get him now, so that your eba will be formed. So that is what we call collision theory. It states that well. I can't hear everybody. That's just it. But there are not let us know that was ṣùgbọ́n this one is ṣùgbọ́n that not every that time particle result in a what reaction. Only small fraction of the total number is what is effective. So if you ask for explain collision theory, this one is okay. If you are writing y, this one is okay. I get him now. But if writing jam, don't know how to state it. Like they will give you options. So you are going to pick the right one there. So now look at it now. Look at this place. For a reaction to occur, called what? Activation energy. But the word when you buy phone, they say you should activate your phone, right? If you don't activate your phone, that phone will not work, right? Now for your reactors also to collide, for them to move together, they must possess energy called activation energy. Because you want to make them to do something else again. So you have to what? You have to have what? Energy, this activation energy. Why? To overcome what? Energy barrier. To overcome what? Now, for example, for water to what? Break bond of maybe for example, now you put what you know they call what's the English of corn? Tricarbonate. What of this is scientific name? Tricarbonate. Don't have scientific name. Potash, right? You don't buy corn in market now, you tell you don't buy corn, right? That's why they don't find English of corn. Although it's not it's Nigerian what was it called? Ingredient of cooking. So it's not in Europe. So you can call it what? You can potash alum, right? No, potash alum is alum. Potassium, right? Corn is called potassium. Okay. Potassium. Please, you know something. I told you don't know anything this morning, but you know something, don't worry. I was happy this morning. Now, potassium, right? Now, this potassium is a metal, right? Good. There is a bond in metal. What is that bond called? That bind all the particles of metal together. If you grind your metal, it becomes powder, right? There is something that bind it together. It's called metallic what? Bond. Metallic what? Bond. Bind it. Now, for water to what? Break down. Water will enter that metal to break it. It's not easy. I get you now. So that thing has its own energy. I get you. That is own what? Energy. So now you need to break that energy barrier. So you have to wet it and what? Become what? Dissolve in your what? Water. But the can dissolve faster if you apply what? High temperature, right? Temperature also what? Makes what? Chemical reaction to come in what? In time. It accelerates what? Rate of what? Chemical what? Reaction. So now, whereby that's when they say what? The colliding reactor must multiply a certain amount of energy called what? Activation of energy. And now is energy a chemical reaction? Read the hand. Is equivalent to energy barrier that must be overcome before bonds are stretched and sufficiently broken to enable the reaction to take place. That's just it. That's not about activation energy. So now look at this. Now look at this reaction here. Look at this reaction here. Look at this reaction here. We have exothermic reaction and endothermic reaction. Who can define exothermic and endothermic reaction for me? Marvelous. React splits. Okay, about talking. Exothermic reaction is what? Okay, to the surrounding, right? Now, out of exothermic reaction, endothermic, away of it from the what surrounding into a reaction, right? Into a system. Now, look at it, you have to study it the way it is. If you're writing why, you have to what? Be able to what? Draw it, pen down number, so that you will be able to draw it. If you have to draw it. Now, look at it now. This is activation energy here. Can you see the activation energy for this endothermic is not that much. This blue line shows activation energy. What of this one here? This activation energy for this endothermic is very much, right? Now, for your reaction to take place, you have to supply it for this one, right? Maybe your cooking, is it endothermic or exothermic? You have to supply it, right, from the surrounding to the system, right? The food there is what? Is the system, and there is what? Is the surrounding. Is the endothermic, right? You are supplying it, right? It's right. So now that it is what? Is an energy. It's energy. So now the energy there is not enough for the food to be done. So it needs more energy. That's why endothermic reaction has a lot of activation energy. JAMB is very wise. Yes. They can tell which one has the greater activation energy. Is it endothermic reaction or exothermic reaction? Which one has the greater activation energy? Is it exothermic reaction or endothermic reaction? Endothermic reaction, right? They need the greater energy for the reaction to take place, right? Endothermic reaction, they are very technical and setting their question now. Yes. It's much make I know what. Now, what is yes? What does it that you say yes? So maybe to do what you didn't even think of doing. Now, let's go on now. So please take note. This is a question here. Which one has the greater activation energy? Is it endothermic reaction or exothermic reaction? Is it endothermic reaction? So they will not tell you that energy, when energy is absorbed from the surrounding, is there, they will not ask that kind of question. They are not that one in those days. They will ask you, they want to check how you can think. So exothermic has a greater activation energy, and your product, this is your product here. Yeah, for this is your product here. For you to draw, you start to react from this place. So now at this point here, it's called activation complex. If you want to give birth, like a pregnant woman of 9 months and 9 months plus, what will happen? The person will not be comfortable, right? I'm asking people to be more, right? Now the person has processed something else again, extra energy in it, right? The person want to what? Decompose, right? Now look up now. If you supply it to this thing now, those particles, they have processed a lot of activation energy. They are not stable. They are not what? They want to decompose. What they fall, that's why your beans, I let me do now. Your beans, or let me, what can I use? Alright, they are not stable. They want to decompose. Your product want to be formed. So now, therefore, when they process high activation energy, they are not stable. So at the point in which they are not stable, they are called activated complex. What did I say? Activated complex. Now that point at which they are not stable is called activated complex, and this is the point. You call it what? Activated what? Activated complex. So they are not stable at this point. So they want to decompose. So at this point they will now start decomposing to form what? Products. Because they are possess what? High energy content. They are possess what? So a point whereby a reactant possess high energy content is called what? Activated complex or what? Or energy profile diagram. This is called what? Energy profile. I'm not putting that. This is called what? You can see. This is called what? Energy what? It's down here without bit. This energy profile what? Diagram. So at the point where they contain what? High energy content. High energy content on the what? On energy profile diagram is called what? Activated what? Complex. So now because of what? They are not what? You can judge they are not stable at this point. I get you now. So activated complex is point whereby a reacting particle possess high energy content, whereby they are not what? Stable and what? Readily decompose. And readily what? Ready to what? Decompose. Ready to decompose. So they are ready to decompose. Am I getting now? So you can jot down, you can jot down, you can jot down. So now good. We is where we stop last class. We will now start today's work. So even though you are new today, you have understood this thing now because I have revised it. And even though it's old, I have revised it. And if you don't know chemistry in your life, I have revised it. So it's what you have been doing every day. You are cooking every day. You are eating every day. Are you ready now? Now yeah, look at it now. Look at this. This thing is very important. Jam my question from this thing. Eléyìí. Please. 1, 2, 3, 4. Okay. We have 6 factors affecting rate of chemical reaction. We have how many factors? 6. Okay. Now, but you can use collision theory to explain what? How change in temperature affects. Collision theory is when particles are colliding, right? To become what? Product, right? Now, we can use collision theory to explain how temperature is what? Is affecting what? Rate of chemical reaction. How temperature is affecting what? When you say affect can be positive or what? Negative in chemistry. Now, a concentration, how is affecting what? Rate of chemical reaction. Concentration is used. Nature of reactant, how is affecting what? Rate of chemical reaction. So, we can use collision theory to also explain what? When you say nature of reactant, the reactant is used. If those two reactants they don't like each other, will they collide? So collision theory can be used to explain nature of reactant, how it affects your chemical reaction. And what period of catalyst can also be used. Collision theory can be used to explain period of catalyst, how it affects your rate of what chemical reaction. Please, I want you to listen attentively very well. I want to listen attentively very well. Class, how many factors do we have in? Repeat it 3 times. Repeat 3 times. I can't hear you now. The rate of chemical reaction depends on what? Nature of what? 1, I can't hear you. That's how many now? 6. Okay, make one, make it odd number. Nature of what? Concentration and what? Pressure, right? Talk, when you talk, you will not forget. Why is sleeping? Talk, if they teach you something, you should know it. Talk. Okay, now good. I would like to listen attentively. I will give you you need to jot down, no problem. I think you need to have notes. Now, effect of nature of reactants. If you see now, sometimes some people they are mingling with each other. I don't know now because they like each other. You see Nifemi Favor, they are always moving together. You see Victor and Waliu, they are always moving together. You see this guy and this girl, they are always moving together. is their nature. They like their what? Nature. They like their what? They like their nature. So as the human being is selecting also, all these non-limits also, they are also what? Selecting. Now, the rate of chemical reaction is what? What of influence is affected? Is affected. Your grammar must be very good. You have to be very good in vocabulary. Is affected by what? Taking part in what? In the reaction. If they don't like each other, they will not react. Maybe they like each other small, they will react slowly, one man lower, before they become friends. I let him now. Taking part in reaction. For example now, under certain conditions. Now, under certain conditions, hydrogen and chlorine what? We combine vigorously. Very fast. They will combine very fast. I get him now. Under certain conditions. But what? Only slightly. Under same condition. If you use that same condition in which hydrogen and chlorine combine together. Now, if you use that condition for hydrogen and nitrogen, they might know what? They might react slowly. I get you now, but this is not where exactly we are going to. Oh yeah, this is the main talk. Also, when do you know what they call electrochemical series? Electrochemical series. Do you know what they call electrochemical series? I normally use electrochemical series to explain this. Well, what's the acronym I normally give you? Please, sir. Call what? Mr. what? Abu what? Zaria. Into what? Into the lab. He can what? He can move some gold. He can make gold. Some gold. Gold is natural. Or is there any way of making gold? Now, P is representing potassium, right? Now, let's write the symbol. That's what? K plus, S representing what? Sodium. That's what? Na plus. C representing what? Calcium. That's what? Ca2 plus. M representing magnesium. That's what? Mg2 plus. Let's see how I'm explaining this nature of reactants. Now, A representing what? Aluminum. A3 plus. Z representing what? Zinc, right? Zn2 plus. Now, this is what? Fe2 plus. Sn2 plus. Lot of lead, right? Pb2 plus. Hydrogen. Hydrogen ion. That's Cu2 plus. Copper, right? M is what? Mercury. Out of S. If you are sick, I'm coming there. Mr. BJ told you something yesterday. Okay, let me assume that somebody has written this for you before. Let me assume that I'm the first person. All these ones, they're not called displays. We use displays in chemistry. What one displays? To send away from its position and take that position. Now metals can what? React with water. They can react with acids. Look at it now. Zinc. This is zinc, right? It can react with what? Acid, right? One of the properties of metal is that they react with acid, they react with water. But not all of them react with acid, not all of them react with water. In an acid, there is something that is composite, in an acid. What is that thing? Hydrogen, right? Now look at it now. Hydrogen is very composite in an acid. I'm explaining now. Now you are going to jot. Hydrogen is very composite in an acid. Now this zinc here, because it's higher in an electrochemical series, zinc is a boss to hydrogen. This is the element of the boss. How powerful they are, this is the element. How powerful they are. I like to now. How their positivity is more higher, is arranged like this. I get him now. The order of positivity, the decreasing order of positivity. This one is more electropositive than this. This sodium is more electropositive than this. This is more electropositive than this. I get him now. The decreasing order, decreasing. Everything now, all the arrangement of what? Positivity. Now look up now. Zinc can react with what? Can displace what? Hydrogen from what? This acid. this SO4 will now come to zinc. That's what zinc what SO4. Now where is the hydrogen that will displace? That's hydrogen gas, right? So now the time in which zinc can displace this hydrogen gas, hydrogen from this acid, you can compare that time with the rate at which this one will send it away. Now if Tinubu come here now, all of you close this place down, what will happen? You never, before you say what are you going to do, everybody wants, because he's a boss, right? Okay, if one shaman now come, that we will still be please sir, we will not want to we will still be begging, right? Okay, if one oga one street come also, at least it will take a process, right? You can't just come and say you close down, right? Now what I'm trying to say is that the way we are going to react to the order is more, it will be more faster, it's more slower than each other, right? Based on the hierarchy of that person, right? That's how it is also. If you want to what, if I want to react with what, this acid, the time it will use to displace this hydrogen away for hydrogen gas to be formed, it will what, take more time, because this one is more superior than this. It will take more what? Class, it will take more what? It will take more time, because of zinc is more superior than what? Iron. I get you now. So that's why they said iron is, when iron is placed in a dilute hydrochloric acid, there is a slow what? In hydrochloric acid, I'm having hydrogen, right? Acid. This is also an acid, right? So hydrogen will be displaced. There is a slow evolution. When they say evolution, it comes the same time as what? It has or what? Libration of what? Hydrogen what? Gas, right? Right. Look at what I said. You take piece of what? Zinc. When they say rapid means what? Fast. Because of what? Why is reaction rapid? Because zinc is more what? Is more positive, has a greater positivity than what? Iron. I get it now, and is higher in what? Electrochemical series. So now as I'm getting closer to hydrogen, if they are reacting with metal, with acid, I get it now, the reaction will be what? More slow. I get it now. So that we are talking about what? Nature of what? Now this one gives you your hierarchy of your what? Of the metal. I get it now in what? In the electrochemical what series. Now which one is the boss between hydrogen and copper, hydrogen and mercury, hydrogen and silver, hydrogen and gold? Which one is the boss? Hydrogen is the boss, right? Which means can copper or mercury displace hydrogen from an acid? No, because hydrogen is the boss. So nature of what? Reactant. Esther, nature of what? Nature of reactant. So that's just it. So therefore, look at it now. With a piece of gold, there is no evidence of what? Reaction. That's why water cannot react with gold. I get you now. Zinc, I get you. Magnesium can react with steam. Magnesium can react with steam to liberate hydrogen gas. It will form what? Magnesium oxide plus hydrogen gas. I get you now. Metal can displace hydrogen from water. I get you now. But sometimes the water has to be what? Of high temperature, like steam. I get you now. So now sometimes you have to eat the metal, like iron. Now you have to eat the iron. You have to eat that. For iron to react with water, that water iron cannot react with ordinary water. Iron must be what? Iron must be heated to red it, and the water it will react with is what? Is steam. In form of what? Gaseous state. I get it now. Then it will now form of FeO plus what? Hydrogen gas. For it to react with steam, it must react with steam, and the iron must be what? Heated at what? Red heat. At what? Red what? Heat. So can you see that magnesium can react with water, but not ordinary water. The water must be a what? A steam. But iron can also react with water, but the water must be a steam, and iron also must be what? Must be heated. Must be what? Heated. Not at what? Red what? Come and eat it. Come and you're not red. I never eat something you showing red. That one we call what? Red what? Eat. red what? Heat. That's that. Which means for iron to react with water, it takes a greater temperature because iron must be heated at high temperature. Your water will do what? Steam also. But for your magnesium to react with water, you don't need to create some magnesium. It's only your water that must be what? In form of what? Steam. And it's because of what? They are more powerful than each other. So the reaction will be slow here, the reaction will be fast here. I get it now? They are powerful than each other. So now, that's just it. So that's why your water cannot spoil a real gold, not the one you are buying from those small amount. Water cannot spoil what? A real what? Gold. Isn't it? Water cannot spoil a real silver. Am I correct now? Because of what? Those metals does not have power to displace hydrogen from what? From water. I get it now? So they cannot react. So that's the mean they cannot what? Or can water react with a real gold? Can water react with a real silver? They don't even use copper to electroplate metal. Because of what? It doesn't react with what? Water. Am I getting now? So therefore, from this now, this is now the rate of chemical reaction is what? Is determined by the chemical nature of what? The reactant. Chemical nature of the what? Of the reactant. As different substances have what? Different energy content. Now different substances have different what? Energy content. So that's just it. Different substances have different energy content. So when iron is placed in dilute hydrochloric acid, the reaction, the evolution of what? Wake that girl up. Let's split. Wake up. The evolution of what? Of hydrogen gas with now is what? Is slow, right? There's no now, and with a piece of zinc, the reaction is what? Rapid. Now, and with a piece of gold, there's no what? Visible reaction. I get you now. So just the rate of chemical reaction is determined by chemical nature of what? Of the reactant. As different substances have what? Different energy contents. So you can explain nature of reactant now, right? I use water, I use what? Acid. The water I use magnesium and steam. Here, this is gas here, this is solid here. I use the iron, red heat iron, and what? Steam. And I use what? Zinc, iron, and gold here. Reaction is not, is fast, is rapid. Reaction is slow. No visible what? Reaction. Am I getting now? If you are sleeping, always go and raise your face. Don't sleep. This is not time to sleep. Mason, G-Mason, this is the moment of destiny. This is the moment where you are destined to know chemistry, isn't it? When you are not sitting around that time, now let's go on now. Effect of what? Effect of what? Now, constitution of reactant. For example, now you cannot compare a coke that you drink and a coke that they have put water, a bottle of water in it. Is it comparable? They have higher concentration than each other. So therefore, effect of constitution of reactants. Now, an increase in concentration of what? Of the reactants will result in a corresponding increase in effective collision of what? Of reactants and S. The rate of reaction, the rate of reaction while a decrease in the concentration of reactant will have an opposite effect. So and what they are trying to say is that if there is increase in concentration of the reactant, the rate of reaction will also what? Increase. I get you now. The speed of in which the reaction will come to end what? Will be very fast. But if the concentration is decreased, the rate of reaction also what? Will decrease. Am I getting now? Now look at it now. Now for gas, concentration does not affect gas. What are the reactions that involve gas? Hydrogen gas plus what? Chlorine gas to give what? Hydrogen chloride gas. For you to form acid, what are you going to do? You are going to dissolve this gas in water, right? It will now form what? Hydrochloric acid. Now when I say pressure for gas, you have to put them in one small container. If you put pressure in this place, if you put gas in this place, they are free, right? They will do, but when you put gas inside this small container, you now tight it. You have increased the pressure. That is the meaning of pressure for gas. You have what? Increase the what? Pressure. So if the container you put a gas is very small, what are you doing? You are increasing the pressure. You are increasing what? Now, so, and you lock it, oh, not that you open it, oh, you lock it. I get it now. So now, if they now, so pressure affects. So whereby, therefore, if I put my hydrogen gas and chlorine gas in my food flask, and I put my hydrogen and chlorine gas in this marker, I lock it up. For example, I'm just giving you an example. Which one is good? When will they react? Which one is going to react fast? Is it when I put it in this place, or when I put it in my cooler? Which one? When will they react fast? The one I put inside this marker, right? Because of I have increased the what? The pressure. I have doubled the pressure, right? So now gases will react faster at high what? Pressure. Because of what? There will not be space for them to what? To move. So they don't have choice. They will keep collide. They will keep what? They will keep colliding. But when we say cooler, what will happen? Is a free word. They will be what? They will move there, right? The collision will be very, very small. By that, the reaction will not come to the end in time, right? Hope you are getting it now, please. That girl, hope you are here. Firdaus. So hope you understand what they call pressure, right? For gases. You will see water in lighter, right? Because of the pressure is very, very high. But when it burns, what's going to happen? When you are free, there is a free what? You have decreased the what? The pressure. You know they will not do what they're supposed to do again. And God have given them what? Freedom. So now, pressure affects the constitution of gaseous reactant. For example, emission of what? Hydrogen and chlorine gas will react twice as fast. If the partial pressure of the what? Hydrogen is and chlorine is what? Double. It will double their pressure. I get it now. Now about this is for pressure. Now, concentration does not have effect on gas. Jam question. Which of the following does not affect gas? Concentration does not have effect on what? Gas. But pressure have effect on what? Only gas. Only gaseous reactant. Say gaseous reactant. Say gaseous reactant. Gaseous reactant. So only pressure affects what? Gaseous reactant. Concentration does not affect what? Àwọn kí ni kò máa jẹ́ lẹ́nu ṣé àyè òní máa ka when you are eating it in your mind, I know it's very hard for you to pronounce, isn't it? We are saying gaseous reactant. When you pronounce something, it will go into your brain, it will go into your mind, you will know it very well. So you will be talking to yourself when reading, pronounce things. Let's go get it now. Now gaseous reactant. So pressure affects what? So gaseous reactant. So when you double the partial pressure of each gases you have reacted together, it what the reaction rate to what will be very, very what? Fast. Now, okay. So now look at it now. Apart from they have talked about gas now, don't talk about solid and liquid reactants. Now, solid and liquid reactant is what? Is what? Is unaffected by what? I've told you, when you sit in CBT, we don't pick it. They let them have beer. They let them parents and not beer. Because we do the right thing to you. You want to listen, no focus, important so. Now, where am I now? The condition of solid and liquid reactant is what? Is unaffected by changes in what? In pressure. For instance, in the reaction between hydrochloric acid and what? Reaction with hydrochloric acid. Where is hydrochloric acid? HCl, right? HCl, and what? Magnesium and magnesium, Now hydrogen gas is given off. What do I say? We know now what do you expect when metal reacts with acid, right? Now acid, even with metal that are higher in the chemical what series than hydrogen. So hydrogen gas is what? Liberated, right? Now hydrogen gas is given off. You can see the different synonyms they are giving you. They can use liberated, they can use giving off, they can use is in fact of hydrogen gas, they can use evolution of what? Hydrogen what? Gas. Hydrogen gas is giving off. That's now what? MgCl2 plus what? H2. Hydrogen gas is what? Is giving off. This is product now and this is reactant now, isn't it? So that's just it. But look at it now. Hydrogen gas will be given off in time if this acid is very, very cold. if they open the cork acid in a room, like you imagine, you don't want to stay there. If this acid is very very cork and you now cut magnesium rebound, Firdaus ọmọ ẹgbẹ́ ọmọ ẹwà jókòó tí wọ́n nígbà gbígbé máa ń gbà yìí kí máa gbá dáadáa ibi tó jókòó sí ẹ my Firdaus ní nínú ẹ̀kọ́ tó sùn bẹ́ẹ̀ yẹn ìbẹ̀lẹ̀ ẹ̀kọ́ jókòó sí ohun tó ráyè sùn yẹ bóyá kọ́ra. Ọlọ́run ọba o. When they put magnesium into an acid that is very concentrated, what's going to happen? There will be what? A fast effervescence. What did I say? Pronounce this word, effervescence. A fast effervescence of what? Of hydrogen gas. A fast effervescence of what? Hydrogen what? Gas. Now, but if you reduce the concentration, like if you dilute the hydrochloric acid again, if you pour more water, how do you dilute? You pour water, right? When you pour water in this acid, everything now, maybe this one, maybe when it's in a pure form, it might take what? 2 seconds. But when you add maybe 10 cm of water, I get it now, it will take maybe, for example, maybe 7 seconds. What happens to the rate of chemical reaction is getting slower, right? Getting slower. So now therefore, if something is very poor, I get it now, the reaction between them will be very very fast because it's more powerful. The energy content is high. I let him now only let anybody pa. So the energy content is very high. If something is very very poor, so it is going to attract any other thing that is surrounding it as fast as what possible. Am I getting now? You can see collision theory. We are using collision theory to explain this. Now look at see this. Can you see this? Can you see this? A lower concentration, slower reaction. Look at the particles. They are far to each other, right? A higher concentration, faster reaction. Look at the particles. They are closer to each other. One because of the concentration is what? Is very very high. Can you see it now? So higher the concentration, the faster the rate of chemical reaction. The faster the reaction, the lower, the slower, the lower the what? Lower. If the concentration you use lower for concentration, you use slower for reaction. I let you know rate of chemical reaction, you use higher for concentration, you use what? Faster for what? Reaction. You should know how to put your adjective to describe them. This is an adjective we are using to describe them. Am I communicating now? So now concentration and reaction rates. So now the rate of reaction is determined by what? Say effervescence. Many times for the effervescence. Like I have told you, maybe it use 2 seconds. When you be diluting the water at the point you be taking it many times it will stop once. It might take 7 seconds. When you put more water again, it might increase to 15 seconds. When you put more water again, I get it now. Measure the time taking for the effervescence, right? The concentration of the acid is varied. Now that when they say varied, it is changing. I get it now because you are adding what? More water. Why the what? Mass metal is still constant. The metal, the amount of mass you are putting is still the same. I get it now. Now, I have shown you the other one, isn't it? Now look at it now. Look at it. Look at it. Can you see? You can see now. Can you see this? Okay. Now, concentration effect on reaction rate, right? Now, the more concentrated, the higher the reaction rate. Now, you can see here. You can see this diagram here. You can see that the concentration is low. That's why they are not colliding very well. But you can see they jump back here because of what? The concentration is very very high. Am I going to get it now? There's something. They say like I said, all this coke, they can melt something. Isn't it? They can melt what? I think I heard that they can melt pin after 3 days. I asked somebody says so. So when you put pin, after 3 minutes you melt it. But when you go and put your yamilu coat there, go and yamilu your lacasera. I get him now. Go and yamilu your, you go and put water. When you add more water, you will not be able to melt it. I guess because the concentration is what? Is very low. So we use fast and low for concentration. So we use slow, we use high and low for concentration. We don't use what? Slow and what? And fast. For what? For I didn't say she's not doing like Casera, she's not doing cocoa. I normally drink it, so I have them at home very well. I get him now. No, they are the mixture, they are the some of the things that they use. I get him now. My react with what? Meta, I get him now. Even though the drugs you use, there's an acid, there it is. Some people they drink it, they will have energy. Now look at it now, let's go on now. Now what's the next part now? Somebody will summarize, you are going to summarize everything I've been saying this morning on each factors. You summarize the nature of reactants. On terms of concentration, I use magnesium and hydrochloric acid. I get you now. What's going to happen? I will keep the mass of magnesium constant. I will be diluting the hydrochloric acid, right? I will be checking the time of what? I will be the sense of what? Hydrogen chloride, hydrogen gas, isn't it? Now, first thing, use a very concentrated hydrochloric acid, pour the magnesium, what we call ribbon in it, cut it in it. I get him now. What's going to happen? There will be a quick what? A 5% of what? Hydrogen gas. Now, when you dilute or when you reduce the concentration of your hydrochloric acid, what's going to happen? The reaction will be more slower. I get him now. As that's how concentration will affect the rate of what? Chemical reaction. So now, for a higher concentration, there will be a greater collision between the reacting particles. But for a lower concentration, there will be what? A lesser collision between the reacting particles. And because of higher concentration, concentrated reactant has high energy content. As what? To attract other reacting particles. Please. Now, effect of temperature. JAMB requires you to know two things. Two explanations on effect of temperature. This is the explanation you need to know on effect of concentration. Effect of temperature. JAMB also wants you to know this. And another example also. We also use this as an example under effect of what? Temperature. And there's another example we are still going to use also. That's based on aims and objective of what? Of JAMB. Hope you are written jot this thing down. Fast effervescence. Fast what? Effervescence. I'll switch off the fan, don't worry. I'll switch off the fan. But people are not sleeping again, right? You are switch off the fan, right? Now let's go on now. Now, based on JAMB, magnesium plus hydrochloric acid aqueous solid. What's going to be formed? I'm in the explanation of the effect of temperature now. What's going to be formed? Magnesium chloride plus what? Hydrogen gas, right? Now, when you pour your magnesium ribbon in hydrochloric acid and the temperature that is there is 10 degrees Celsius, that you apply is 10 degrees Celsius, you can note the time of evaporation of what? Hydrogen gas. If you increase the temperature for the second experiment to 20 degrees Celsius, everything now, eating the mixture, the effervescence of hydrogen gas will be very, very what? Fast. Because of what? You have increased the temperature of the what? Of the reactants. So they will react what? In time. They are going to react what? In time. So why will they react in time? The the reactants are going to gain kinetic energy. Listen very well. The temperature you increase, because of your increase in temperature, you are going to increase temperature by supplying heat, right? Heat is what? Is an energy, right? Energy can either be what? Created, not what? But can be provided from what? So now the heat you supply, the energy you supply, once the reactant particles receive the heat, they will convert it to what? Kinetic energy. That's why when you see your water boiling, what happen to that water? You'll be moving, they'll be dancing. If you are cooking like also, what they those guys also be what? Dancing. They'll be jumping up, jumping down, right? Because of what? They have gained kinetic energy. The heat you supply are converted to what? Kinetic energy. Kinetic energy or what? Motion, right? So therefore, when you apply it, I get him now. So easily this magnet will be melted easily in the mixture. I get him now. So the particle is going to be moving easily, and this the particle of hydrochloric acid also will move easily. So the collision will be what? There will be high frequency collision. When they say frequency, frequency means what? Occurrence. Frequency means what? There will be high frequency, or I don't know why I was talking in my class, so I'm coming there. I'll get a good kid now. High frequency of what? Collision. There will be high frequency of what? Collision. That the rate at which they will be colliding will be very, very, very what? High. Everything now, the rate at which they are colliding will be very, very high. I need feeders at this place, or this place. I need you. Don't worry. I need you. I need at this place here. The rate at which they will collide will be very, very what? High. So now, how am I explaining this now? When it is supplied to a reacting particles, the heat energy supplied will increase the temperature of the mixture, which the heat energy is converted to what? Kinetic energy. So the reacting particle is going to what? We collide. We what? We move. We collide at what? High frequency. There will be high frequency of collision between the reacting what? But due to the kinetic energy in there, so it will increase the speed of the what? Reactant. After that, let's move. 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 That's the kinetic energy, isn't it? It's very simple. It's not simple. It's very simple, right? So now you now see that rice jumping and the water they be meeting each other, colliding with each other, bang, 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 as if they are dancing, as if they are playing music in their world, right? They will be happy, they will be dancing together. Let's joy. Rice, you don't eat, rice will not move, rice will just be there, meke. But when you supply it, that meke will go, right? Then start moving. Now, that's it. Every class, For both exothermic and endothermic reaction. What is of exothermic? When it is given out. What of endothermic? When is it given out? It is generally what? Double the rate of reaction. If you don't talk, I'm coming there. My bello, increases. Increases. That's just it. Another example JAMB wants you to use is reaction of hydrochloric acid, aqueous, and sodium trioxothiosulfate 6. This name of this is called what? Sodium Sodium, trioxo. Tri means what? 3, right? Oxo is what? Oxygen. And this is sodium, right? Thio means 2. Thio means what? 2. Thiosulfate. I get it now. 6. Now, when you say thiosulfate 6 ion, this is the ion. H2O3 2 minus. This ion is called what? Trioxo. I can't hear you. Say it after me. Trioxo. Thio. Oh, I want that energy. Thio. You have to say Thio. Sulfate what? 6 ion. So these 2 minus will come to this place when it's combining hydrogen and nitrogen, but no problem. We'll do that one under oxidation and reduction. All this IUPAC is very compulsory for you. Now, when they react together, when you apply heat of 10 degrees Celsius, there is something we call colloids. Colloids. Colloids of sulfur. Colloids of sulfur will be formed in the mixture. I get you now, but it can take time if your temperature is very low. But colloids of sulfur will be formed in time if your temperature is very, very high. Now, when they react, there is no anything displacement of hydrogen chloride gas, but colloids of sulfur will be formed. I get it now. I can say colloid of sulfate ion. Let's say colloid of sulfate what? Sulfate ion. It will be what? Formed. But it will be more faster if the temperature of the reaction is increased. The colloid of sulfate ion will be what? Will be formed faster if the temperature of the what? Reaction is what? Is increased. Colloid means seeing what? Cocoa. You can also you can also make your eba or your amala. You can see cocoa, right? You can assume is what? They are what? Colloid, right? Colloid. Say colloid or something ion. You now say cocoa. I can't say cocoa. Magically you don't say cocoa. But if you increase temperature, the cocoa will be very, very well. You form faster. I get him now. This is an example. You don't know. This is your water here. When you pour this solution, you are going to mix this salt with water. It's a salt. You mix it with water. The water will be very, very, very pure. When you pour inside water, will you look as if you pour something there? Some can even drink itself. The person will not know until the person taste it that day. Now, when you pour this salt inside water, I get him now. This acid also, you have your acid, it's neat. I get him now. It does not have color. I get him now. You now pour them together. If you pour them together, if there is no temperature here, your cocoa will not be formed. What's that thing? Colloid or sulfate ion will not be what? Will not be formed. Or you can say precipitate of sulfate ion. You can say what? Precipitate of what? Sulfate ion. Ẹ ti mọ̀wé jù. Ìwọ́n tó bá mọ̀ wò ní ìkọlọ̀ wẹ̀rí ẹ lódò. What I say? Precipitate of what? Sulfate what? Ion. That's what? Cocoa. If I now supply it here now, cocoa. I get him now. We start what? Forming. We start what? So what you assume is what? Once you start seeing precipitate of sulfate ion or what? Colloid of sulfate ion, the reaction has taken place. The reaction has what? So at a higher temperature, there will be what? A faster precipitate of what? Sulfate ion. Or there will be what? A faster colloid of sulfate ion in the mixture, in the reaction. Am I going to get it now? sometimes ó máa ń fẹ́ wá ìgbà mi ó dé máa fẹ́ lọ tó bá ti fẹ́ wá gbà mí ó máa kíláàsì ó máa sọ̀rọ̀ yẹn wá ní ó bá ti fẹ́ lọ tí ó bá sùn ó máa wà ní ẹ̀mí ẹ̀kọ́ ó wà ní ẹ̀mí lẹ́ẹ̀kọ́ máa study dáadáa. Now that's just it. So look at it now. What is happening? The temperature also will increase the kinetic energy, so they will collide in time to form what? The colloids of what? Sulfate what? Ion. Or precipitate of what? Sulfate what? Ion. Am I calculating now? What is happening to this graph here? What is happening to this graph here? High temperature, low temperature. Can you see that at high temperature, this immediately you see a horizontal line, your reaction has come to the end, right? At the faster rate, your reaction, when you have high temperature, your reaction has come to the end here because we are going to see horizontal line as from this phase. But look at where you go and see horizontal line here is if it is low temperature. The time it will take for the end to come to the end, this is your time axis. The time is very high because as we are moving, this point is 0.0. Your time is increasing 1 second, 2 seconds, 3, 4, 5, 6, 7 seconds. But look at this time here, 4 seconds, your reaction has come to the end. I don't know when you see this horizontal line, your reaction has come to the end. Good. You have learned how many factors affecting the chemical reaction now? 3. I use sodium, if you have sense you write it down, trioxo, thiosulfate, what? 6, what? Salt, right? Additive now is solution with what? With hydrochloric acid. Say hydrochloric acid. Hydrochloric acid. I like calculating now. Good. Hope you are digesting it. Hope you are assimilating it. Any jam question? I pray you can finish this thing today. We'll do CBT. You are the course. I don't have a question of busy. But when you are said you are giving, I remember that it's true. I need to warm you up. I get it now. Fear of failure, guarantee failure. You can see she shake. She's unshakable. I have never touched her. I get him now. I probably normally get scared. That's why I touch him. Look at him there. Which boy? No, you don't shake. It is eyes. Now, I haven't jotted down. Can I play the board now, right? Oh yeah, now let's go now. Surface area of reactant. Look up. Surface area reactants. Now let me have this surface. Where is surface? This is a surface, right? I get it now. This is what the whole of this is what area, right? Now in chemistry, something that is in powder form has a large surface what area, has a large what, but something that is in solid form, maybe cocoa, that is one like this, that is big. Something that is in something that is in form of granule. I want to look for that grammar. Granule. I get him now. Like shifts. Shift size, not shift size, right? Shift size, right? Has a smaller surface area of contact. Has a what? I will tell you the reason. Surface area of what? Of contacts. You have gone, right? You have seen her, right? Okay. You don't want to check on you, right? So you want to collect you. Okay. Now, last surface area of contact. Last surface area of contact. Now, something like powder form has a what? Last surface area of contact. I will explain to you. Sometimes what? In form of sheep, plantain sheep, all this big size. I get it now. Has a what? Small surface area of contact. Now, when you put your Maggi inside soup, the Maggi soup you throw Maggi inside, and the one you squeeze your Maggi in form of powder form, which one is going to mix with your food in time? The one you throw inside it. The one is, I thought something is happening to your brain. The one you squeeze, right? Because of that water, the liquid, the liquid in the food, the what mixed with the what? Powder, with the powder one in time, right? Don't enter it, penetrate, right? Because you push all the powder there, right? But the one that is very, very solid, like when you go and buy all those strong Maggi and your gas has finished, maybe your food is about to done and you have forgot to put Maggi and you don't put Maggi last, you now go and throw it, like you will see it in your food like that. You have seen that kind of food before, right? It will still melt, though. I'm just assuming your gas car is about to finish and the food is about to done, and maybe it's just 2 minutes. It will not circulate like the one that you sprinkle, and the gas car is very, very hot. It's still working. It's still there's enough gas there. Hope you understand what I'm saying. So now, this is your water. This is your water. Look at it now. Look at the area the water is touching in this Maggi. Look at the area the water is touching in this Maggi. Can you see that it's not touching everything? It's not entering. I'm using Maggi as an example. I get him now. So it's not entering, or your plantain chips. It's not entering very well, right? So now, area of contact, area which your reactant is contacting this thing, the area of contact is what? It's small, right? Sarah, the area of contact is what? Small, right? We will say smaller surface area of contact for something that is form of solid what? Form, box shapes form, granule shape, shape. I get you now. But when you sprinkle this thing, when you carry this thing, you not turn to powder, you grind it. I get you now. They what? Scatter everywhere, right? This water can touch every part of this Maggi very well if you what? Squeeze it, grind it, whatever, any garment can use anything now. So just make sure it's in form of what? In powder form. So therefore, water will touch larger parts of this what? Maggi. Everything. So we say it has what? A large surface area of what? Contact. Now, which one will react fast? Is it the one that has a large surface area of contact, or the one that has a smaller surface area of contact? A large surface area of contact, right? So the larger the surface area of contact of your reactant, the faster the rate of chemical reaction. The smaller the rate of what? Surface area of contact, the slower the rate of chemical reaction. I get you now. So they now give us example. They use zinc and ACL. We have zinc granule, we have zinc dust. I get you now. No problem. There's also use marble sheep and marble powder. Oh yeah, let's go now. Let's read. Clear, clean. Now, 1, 2, ready, go. Increase by increasing the area of contact of the reactive substance. This is a very important example of the reactive substance. The area is the surface area of the reactant. The higher is the rate of reaction. Surface area of the solid ground is very smaller form. This is the opposite of the reactive. powdered marble. So the reaction will be slow when compared to what hydrochloric acid and powder. When you use marble chip, like when I say marble chip, you might not understand it when you just assume as you call plantain very what big plantain sheet that is very big. I get him now. So now you can compare it with what powdered marble. I get him now because of what the powdered marble there is a greater density of contact which will increase your greater position within the reacting substances. Am I going to get it now? So hope this thing is still on, right? My cameraman, hope you see on it green light. There's still green light there. Okay. Now, so therefore, where am I? Faster rate. So what do you use there? For example, you have marble chip and marble powder reacting with what hydrochloric acid. Acid that use of hydrochloric acid is very high. Acid. We have been using acid is the beginning of this explanation. If you don't use HCl, you use H2SO4. Acid is very important. Isn't it? So now, marble chip and marble powder. You can also use similarly, zinc dust. Can you see? I get him now. This is what? Combustion. When you say combustion, when something is burning in an oxygen. So this is what metal can combust in oxygen, right? To form another compound. Now, so zinc burns. What burns? Combust in what? Oxygen faster. Now, that will turn your brain. They will give you zinc dust combust more quickly in oxygen. Zinc granules combust than granules. Why? I let you now why? Because of option A. Because of increase in what? Concentration. Option B, surface area of what? Of reactant. Option C, nature of the what? Reactants. Option D, temperature of the reaction, right? Which one are you going to? Which one? It says zinc dust burns more quickly in oxygen than chlorine than zinc granule. Why? What was the answer here? Everything are all factors that affect chemical reaction. But answer is what? B, because of dust has a larger surface area of contact than what? Granules. I get it now. Zinc can burn in oxygen, zinc can burn in chlorine. I get it now. But it will burn faster if you use zinc dust than what? Zinc granules. Now, where am I? Also, zinc dust react faster with what? Hydrochloric acid than what? Zinc granule. Than zinc granule. Than what? Zinc granule. Than zinc granule. Than zinc granule. Now, you can see this reaction, zinc and your what? Hydrochloric acid to form what? Zinc chloride and libation of what? Hydrogen gas. Can you see we have used hydrochloric acid, we use in temperature, we use in nature of reactant. We can instead of H2SO4, we can also use hydrochloric acid. We use it in surface area of contact, isn't it? Which is this? Which one do you also use it? Concentration also, isn't it? That's 4. So we have been using hydrochloric acid everywhere. So now, where am I? So if you have essential or new school or hidden facts, I will see all this explanation there. I'm not waiting now. So you see what the no problem. So now, guys, see what has happened here. So that's what it is. What are the 5 factors that affect rate of chemical reaction? Effect of light. Say light. Do you know that light is an energy? Is it an energy, not an energy? Light energy. Is it an energy, not an energy? It's energy. So now, effect of what? Of light. Effect of light. Light is a source of what? And can influence the rate of what? Considerably by energizing the particles involved. Energy can neither be created nor destroyed, but it can be converted from what one form to what another. So now, by energizing the particles involved, for example now, in bright sunlight, hydrogen and chlorine react explosively. Boom! Everything now, you know they have explained this under pressure. Hydrogen and chlorine, they make use of hydrogen and chlorine. When you want increase their pressure, it will the reaction rate will what double. Now they also want bring what instant the example also under what light, that in a bright sunlight hydrogen and chlorine what react what explosively. In daylight the reaction is what moderate. Any Femi bí o mọ̀ pé ìwọ ló ní ẹ̀rọ ẹ̀ o tó tún ní ṣeré ní class báyìí. What do you call it, Shiri? In daylight, the reaction is what? Moderate. But in the absence of light, it might not even occur in the absence of what? Light. So now, such reaction are what? Known as what? Photochemical reaction. A reaction that involves light is called what? Photochemical reaction. Example is what? Photosynthesis. Photosynthesis. Now, because photosynthesis is what? Light energy from the sun, right? For it to what? It's a reaction. For it to what? Take place, right? No light, no what? Take place. Now, ṣé àwọn èèyàn ní COVID nígbà tó fi bomú ni? Àbọ̀ yẹ́lò jẹ́ kó bomú ni. Now, where am I now? So now, a reaction I use light is known as what? You just be option C, photochemical reaction. Example of reaction I use light, photosynthesis. I get him now. Why can I ask you if you're asking why? Explain what happens when hydrogen and chlorine react in a bright sunlight. What will happen? They will react what? Explosively. If you are not careful, it will cause effects on you also that you are reacting it. I'm not going to get it now. So now, other examples of photochemical reaction include what? When they say halide, what do you understand by halide? When halogens combine with what? Metal, right? Metallic halides. Now, silver halide, silver chloride, to what? Gray metallic or silver. That's one example. Another example is what? Photosynthesis in plants. Another example, methane and chlorine. That reaction is called substitution reaction. It requires what? Light. It requires what? So you have to go and know it in your brain. Jump and say reaction between methane and chlorine is kind of what kind of reaction? It's a photochemical reaction, and is what? It will occur in time if light is being supplied to the reaction. I get you now. So now the composition of what? So from water and oxygen. This is like how do I write hydrogen peroxide? This is me H2O2. How do I write hydrogen peroxide? H2O2. The favor is now become what? H2O plus what? O2. Now you put what? 2 here. How many hydrogen do you have here? 4. If you dash, you have 4 hydrogen here. How many hydrogen do you have here? You have focus. Face the phone, don't back the wall. Face the phone. That's how you say, hey, the way you make me sat down, hey, you can see. That's everybody sat down there. Don't be weird. Face very well. Hey, there's something distracting you there. Maybe I'll bring that one to the front. So that you won't be looking at the front very well. Now, I think you should be split. Okay. Now, this is what? Can you see it's balanced now? 2 oxygen, 2 oxygen. 2 times 2, 4, right? 4 oxygen. So now, hydrogen peroxide. This is called what? Hydrogen peroxide. Why? So we are going to write it down. This is called what? Hydrogen peroxide. Decomposing to what? Water and what? Oxygen in the presence of light. So it's a photochemical reaction. Effect of catalyst. Who can define catalyst? Don't say catalyst is a sort that speed up. Don't say speed up rate of no. Catalyst can also what slow down rate of chemical reaction. Now Marvelous, can you define catalyst for me? Marvelous. No, do you know of Marvelous? Surprising. I have to be marvel at your performance. Marvelous, something is surprising. You need to buy food. Pause it. Effect of the catalyst. Now, what is the catalyst? The catalyst is what? Which alter? What not alter? Changes the rate of what? Chemical reaction, but remains chemically unchanged at the end of reaction. So don't say catalyst so that speed up. No, it doesn't speed. It speeds. It's also what? It slow. Now we have two catalysts. We have positive catalyst and negative catalyst. And negative catalyst normally slows down rate of chemical reaction, and we call that kind of catalyst inhibitor. Inhibitor is a what? A negative catalyst. Negative what? Catalyst. That what? That slows down. Catalyst that what? That slows down the rate of what? Chemical reaction. That slows down the rate of chemical reaction. Inhibitor. Say inhibitor. I can't hear you. Inhibitor. Now let's look at it now. Now some what? Positive catalyst is what? We speed up the rate of chemical reaction. Like that is a substance which what? Alters the rate of chemical reaction and remains chemically unchanged at the end of what? The reaction. A catalyst was what? No, follow me. For the reaction, if the alternative route has a lower activation energy, the catalyst is said to be a positive catalyst. Whereas if the alternative route has a higher activation energy, it's known as a negative. If a catalyst creates a route that has a higher activation energy, it means for the reaction to take place, the reactant must possess a high activation energy. Therefore, that catalyst is what? A negative catalyst. It will slow it down because for the reactant particle to have a high activation energy to overcome energy barrier, it will take time. It will take what? Time. So catalysts that slows down the chemical reaction are inhibitor. So what are those switching there? And the catalyst that slows down the chemical reaction will create a route or no. When they say route, this is it here. Let me show you. This is it here. Where is your activation energy here? This is activation energy, right? Look at this one. A low activation energy using catalyst. Small activation energy. So when you solve that small activation energy, it will kickstart in time. Exothermic reaction has a low activation energy. That's why it can what? It can occur spontaneously. That can occur what? When it is spontaneously. Spontaneously is when something occurs without you supplying it. Spontaneously is the reaction that occurs without you supplying. When you pour sodium hydroxide inside water, that bottle will be hot. And that bottle was not hot before. Why is that bottle hot? The sodium hydroxide and the water has what? Release it to the what? Surrounding. As well release what? To surrounding. That kind of reaction is it exo or endo? It's exothermic reaction. Why is that? Because of they have a low activation energy. But when you pour rice inside water, what's going to happen is anything that will occur unless you supply heat energy. Because of what? That reaction has a high activation energy. So the energy supply will now increase the activation energy of the other particles so that they can overcome energy barrier within themselves, so that they can what? Collide with together with a higher frequency, right? So therefore, a reaction that has a low activation energy, they are very wise. A reaction that has a low activation energy can react spontaneously. That's option C. Can react what? Spontaneously. That's option C. So exothermic reaction, most exothermic reaction has a what? has a low activation energy. That way they can what occur spontaneously. That is without you supplying it. Without you supplying. I thought so. Because jam, they are very well. They will be looking for where to bring question. They will not want to do. They don't want to give you straight question. They want to see how you understand that thing. Don't test your understanding. Nancy is not scared now. I didn't do anything. I need to that. He's right now. I think I need to move to that side now. This one is great. Now, let's study this thing now. Let's study it now. Can you see that this is activation energy for this one? Can you see that it's small? This dotted line. This dotted line is the energy profile diagram that shows what? A low activation energy. This is small. You can't compare to this one that you didn't put catalyst. I get it now? So that you didn't put catalyst. So now, this one I show here is for what? Is it endothermic or exothermic? Exothermic. The product is always at the downside. I get it now? The heat that is released is between this reactant line and your product. This is the heat. We call it heat change. I get it now? This topic is energy and chemical reaction. The calculation of all these things. They also relate. Now, so this is exothermic reaction. Now, so a catalyst lowers what? Activation energy. Lower activation energy using what? A catalyst. A catalyst lowers activation energy. So that the energy that the reaction needs to take place. For the reaction to take place will be what? Low. So we might not reduce the high amount of energy that the reaction needs for the reaction to what? Take place. What does the catalyst do? It lowers what? A activation energy. Move, stand up. Bring that phone. Yeah, I know you are not pressing it. Just bring it. I know you are looking at it. Just bring it. The phone you are not pressing cannot be yours. No. So you can this simple way you can just give your data to be running. In Tinubu regime, you can leave your data and the data is not running. And the data is not running. And the data is not running. Bluetooth is not on. Hotspot is not on. Nothing is on. That will make it on. So definitely is pressing. The phone is what? The brightness of the phone. The phone is bright. So because of the brightness is making it to be on. Naturally, right? Okay. I'll make it low, no problem. It's bright. Your daddy must come before you collect this phone. One light and line. Okay. One light, your daddy must come before you collect this phone. Now, with everything I'm teaching you now, you will now be doing CBT and be having one useless call. Why is your phone hot? Silence, thinking of what to say. That's psychologically, you think of what to say, it does not have excuse. So that which means it has what coincide with the statement saying he's not pressing phone. If you are a fool, your teacher is not a fool. Now, where are you? What does the catalyst do to a reaction? It lowers the activation energy. So which what? So lowers the activation energy, which creates alternative vote. Honor. What means honor? Nifemi, Kogbonro, honor. Everything that is the pass. The reaction is the take place. I get it now. Now, it creates what? Alternative votes. This is where jam normally bring up question. Alternative vote for the reaction. It will I cannot create a shortcut. to reach products. Alternative vote. But guys, I know maybe is not scared. Can you say she's not scared? I already thought she's simple. I know she's scared now. She will eat it or she will receive it. You cannot be scared again, right? Now, already vote for the what? For the reaction to what? For the reaction to take place. To take place. To take place. Now that's just it. Now look at it now. Finish for exothermic and endothermic. Can you see? It's very nice. Look at this nice diagram. Can you see that another part is being what? Taken. I get it now. A low activation energy. I get it now. So this is what EA with catalysts. I get it now. So why this one? Activation energy without catalyst. Activation energy without catalyst is very high. But activation energy with catalyst is very low. I get you now. So it creates another alternative route for the reaction. It creates this another path, shortcut to get what? Where the product side. Now yeah, read. Can jot this down. You can see we use hydrogen peroxide for light affect hydrogen peroxide. Catalyst also affect hydrogen peroxide. That kind of reaction is called photocatalytic reaction. Mo tún rántí kan náà, hydrogen gas and chlorine gas. You can use activated charcoal. Ti tó gbàgbé, let me call it so that I will remember to explain to you. That's what this is. What? Activated charcoal. Activated charcoal. Do you know that this reaction can take place in place of light also, right? It will react explosively, right? So now a reaction that can take place during place of catalyst and light is called what? Photocatalytic reaction. What did I say? Photocatalytic reaction. Photocatalytic reaction. But the reaction now, photocatalytic reaction. Can you see? So manganese oxide. This is the reaction. Break down now. It breaks down. It decomposes in time when you put what? Manganese oxide as your what? Catalyst. Some people put your onions in what? Beef very well. So that it what? Be done in time. Apart from the sweetness, you know it be what? Done in time. Like I can say that onions is acting as the what? Catalyst. Yes. Ewa. So bad dear, go and ask your grandma. Go and ask your mommy. Grandma is too fast. Your mommy will tell you that yes. So bad dear, go to Ewa. My did you know you're more 206, 205 years. Going down there, now, where am I now? There's it. Manganese oxide. Now, let's read characteristics of catalyst. So I color temperature may change, but the catalyst still remain the reaction. I get it now. So and it alters the rate. When they say alter, changes the rate of the speed of rate of chemical reaction. It can slow it down. It can increase the speed. It remains unchanged, but the color can change. But it itself will remain what? Will still remain. A catalyst is specific in what? Action. Like if it is what you want this catalyst to do, it will do it. I get it now. Does not do. At least cannot. Is already. You cannot set a reaction. It's only what effective reaction is already what in progress. Thereby altering the rate of what? Chemical reaction. It does not what? Then can just list which of the following does the catalyst does the reaction. If you go and think a catalyst affect type of product form, it kind of don't affect type of product form. The only thing it does is alter the rate of chemical reaction. It lowers the activation energy. It creates an alternative route for the reaction to take place. Does not be fair. It does not change. And then chemical. Go and read it very well. Day and night, morning and night. It kind of has no effect on the equilibrium position of a reversing. It has no effect of it. It only allows equilibrium to be achieved in time. It only allows equilibrium to be what? Achieved in time. It does not shift equilibrium to the right or to the left. Yeah, we will soon get to that topic. Now, yeah, let's go on now. Present in a very small amount, that the speed of what a reaction of reaction. Now, effect of catalyst is improved by increasing the surface area. Well, how do you improve surface area? By making the grinding in the form of what? Powder. Oyin ti pe you sabi book, man. Look at reaction, look at their catalyst. Thermal, what is it thermal? It's the composition of what? Potassium trioporate what? 6. I get him now. Now that will be 6. Now the form of potassium chloride and oxygen. What catalyst is used there? Manganese what? Manganese 4 oxide. Manganese 4 oxide. It was tó bá ní kò lè move máa move ẹ má worry, máa move ẹ. Manganese 4 oxide máa move ẹ má worry. Ó ti sú kò sú o kò sú rárá, ó reboot mi á lè restart iṣẹ́ yẹn. Synthesis of what? Ammonia, production of ammonia. What do you use? Iron powder. And you see, when you increase the surface area, it will be more effective when you increase the surface area. Now, what of this one? Formation of what? Margarine. That's butter from what? Vegetable oil and hydrogen. They will hydrogenate your vegetable oil. It's going to form butter. What catalyst? Finely divided nickel. Nickel that is divided finely. Not ugly. Now where am I? Like from what? Ammonia, oxygen, nitrogen, nitrogen 2 oxide. Now this is water. What do you use? Platinum. You know that transition metals, they use them mostly as catalyst, right? Platinum is a transition metal, nickel is a transition metal, iron is a transition metal, manganese is a transition. We use them mostly as catalysts. Vanadium is a transition. We use them mostly as okay. It's left to you. Everybody has done the right thing. Your parents have done the right thing. Your tutorial has done the right thing. It's left for you to do the right thing by reading your book, by solving past questions, by what? Be disciplined. I get him now. By not allowing your phone to distract you. We have all done the right thing. God will have you. 7 minutes. We need someone that can explain order of reaction. Then tomorrow we open up the CBT. Yes. CBT, man. I get it now. CBT. This is my first completion chemistry topic, right? CBT. No, Shake, it was doing like this. It was scared. I saw it. Is that what? On display. Where am I? This is that part. After this part is CBT. You will not go and solve past question. Remix, rate of chemical reaction. The other of reaction you see it there. In fact, I get him now. Order of reaction. You go and do hydrogen and a compound, chlorine and a compound. Go and read it. Solve them. It's very important. I get him. That means teaching you and you not do personal work. You have to do more hard work than us. Out of 90%, you need to do 70%, and we is 30%. I get it now. So both of us have to prove what you are not putting 10%. You are not allowed to write the exam. Oh yeah, now read there. Taking part in it. What are species? The reacting particles. The rate between the concentration and what? The rate of chemical reaction. Is the concentration of the reacting particle affecting the rate of chemical reaction? That's all what order of reaction is all about. Is the concentration of the reacting particles, either one reacting particles, either two reacting, is it affecting the rate of chemical reaction? That's all about what? Order of what? Order of reaction. Say order of reaction. This is the subtopic. This is the last one. Order of what? Reaction. Is the relationship that tells us between the constitution of reacting particles and what? Rate of chemical. Maybe the constitution of reacting particles is affecting rate of chemical. That's the one all about what? Order of what? Oh yeah, where am I now? Where am I now? In order to what? Must be obtained. Don't worry, you are going to see the rate equation later. Here's one other. Concentration of all reactant. It depends on the concentration of all reactant. For example, rate of what? We have zero order reaction. When you get zero order reaction, is a reaction in which the concentration of the reactive particle does not affect the rate of chemical reaction. That's zero order reaction in which the concentration will not take part in the rate of chemical reaction. But when you get first order of reaction, the concentration of one reactive particles is going to what? Affects. It's going to take place the rate of, it's going to affect the rate of chemical reaction. When you get second order of reaction, the concentration of two reactive particles is going to what? Affect the rate of chemical. Yeah, let's read. For example, dependent. What about dependent? Depend solely, largely, completely, or what? Of what is one reactor in the reactor. Some catalyst. Number of species whose concentration directly affect the rate of when I say exponent of the concentration terms, power, don't worry, just with any of concentration terms in the rate of the expression well, the correspond to each species in the balance reaction. That's balance equation. When they say stoichiometric equation, H2 Cl2, that's the ACl. That's we have one here, right? We have one here. It does not depend on the stoichiometric what coefficients of the balance what reaction or balance equation. Are you getting me now? So now let's go now. Organizer is always defined with the help of reactant concentration, not with the product concentration. Of an integer or fraction. Can even have a value of 0. Expression in the rate law is given by what? R equals to K square x plus what B. So now this x here, this is and y here is what we are going to add together. Everything now x plus what y. When they say you are going to add the exponent, when they say exponent, the power of the concentration. This is the concentration. But how high the concentration is, this x and y value shows how high the concentration what is. So concentration of B, concentration of A is determined by the what? Exponent. When they say exponent, the power that is on what? A, power that is on what? B. I get it now. So I can say x plus y. So how high the how high the concentration is will be indicated in what? In the power, in the exponents. But no problem, let's go on. Now, all that is designed by rate law. Let's go on. The sum of all partial order of reaction is the overall order of reaction. No problem, let's go on. All these ones you don't really need. of the reaction is written as what? R equals to K A raised power exponential X B exponential Y. The sum of the exponents X plus Y give the final value of the what? As discussed earlier, the value of order of reaction may be in form of the integer, zero or fraction. A graph detailing the reaction rate for different areas can be found below. Now, the order of reaction, that K is always negative. The slope is always negative. And this is the graph for order of reaction. This is the graph for order of reaction. Now, this is no way. I'm going to recognize first order reaction. Now, now, look at this is where I'm coming now. We are done with this topic. We just read. This is final. Hey, my fellows, I don't know the day. You cannot die. Your dream is bigger than that phone. Your dream is bigger than that phone. We are one player to go ahead. 1, 2, ready go. Now, the rate of reaction is independent. When you say independent, the speed of the reaction is not depending on constitution of the what? Of the reactant in this reaction. Ilé ìtú sálọ, ó lè sálọ. Ojú tí wọ́n. The change in concentration of the reactant has no effect for zero order. Concentration has no effect on the rate of chemical reaction. Example of this type of reaction include what? Enzyme catalyzed oxidation. Ethanol to what? Ethanol. Ethanol can be oxidized to what? Ethanol. And the concentration of ethanol is not what? Affecting the rate at which ethanol will become ethanol. I thought it's sorry. I put more force there. Sorry. I don't think it's a period. Now, so you know the enzyme catalyzed reaction. They have used enzyme. They have used catalyst already. And for this now, so therefore the concentration of ethanol is not relying on the rate at which the reaction will come towards end. Now, so it's a first order reaction. Listen. The first order reaction of class 1 ready go. Only one reactant. So because of that reactant will now determine how fast the reaction will be. So which is called first order reaction. First one. I get him now. Sheriff. Now, zero order concentration. Example of first order reaction. This is not hydrogen ion. This is hydrogen peroxide. Hydrogen peroxide. You are saying hydrogen ion. That's H2O2. Now it's the first order reaction. So this hydrogen peroxide, the concentration of hydrogen peroxide determines the rate of the reaction in this reaction here. You go first order reaction. Well, okay, I read here. Is constant and therefore when the rate constant in the reaction in this one, when they say pseudo first order reaction, we have more than 2 reactants, more than 1 reactant. I get it now. But one of them, the concentration will be the one of the concentration is the determinant of the what? Rate of what? Chemical reaction. But this one is just ordinary first order reaction. We have only 1 reactant. But here you can have more than 1 reactant. Well, the concentration of the reactant may be constant. Now this water, the concentration of water is constant. The concentration of water changes. So a reaction that you have water, the concentration of water does not have effect on the rate of chemical reaction. Now, baby, constant. Now, and this is the example. Let's go now. This reaction. Water is less that water does not have effect. Well, let's go now. Second order reaction. Who is that? Samuel. Ó kàn tó tó o kà wọ́n tó wà lójú bọ́ọ̀lù tí ó fi fẹ́ fẹ́ yìí. Àwọn ọ̀rẹ́ náà kò lè fẹ́. Gbogbo àti máa ti kọ́ ògùnà fẹ́. Ó yá listen read. Wà á yẹ wọ́n ti sọ Samuel read. Second order reaction ẹ máa wó yẹn ẹ máa wó yẹn ó yá second order reaction. It's okay. Let's do together now. 1, 2, ready, go. Favor. Sarah. Square. Now, for example, the rate equation can be correspond to what? RKA squared or what? Now, it might be condition of reactant that is one reactant that is double, or condition of the two reactants in total. Everything now, the R equals to AB, the two reactants, or double of. Now, when you have 2A like this, you will now say R equals to KA squared. Everything now, or when you have A plus B. Everything now, that's A plus C or C plus D. This product C plus D. That's 1, 1. That's your R, K, A. I guess in B. Don't need to how to learn how to calculate. Let's go. Example of second order reaction is this. Nitrogen 4 oxide and what? Carbon 2 oxide. You form nitrogen what? 2 oxide and what? Carbon 4 oxide. This is not really necessary. It can be noted as well. One order of reaction is fraction. The reaction is what? Now, other complex reducing. Or an example of chemical reaction in which a fraction reaction is, or there is pyrolysis of what? Acetaldehyde. That's under aldehyde. If reaction is what? 1.5. Say, glory be to God. I want to pray. Start from. I knew I was coming and it was still clapping. I was like, there is one girl in that act. Her name is Rachel. You are making her she should just like this. I will not stay. If I get her, I also stay. She should not do it. I also stay. I will just broke her. I will just fight by. I want to see what happened. But as I come, I was expecting you to be scared also. So if you're not scared, I want to share it right. Share it with you because I'm like, man of God. So tomorrow we are going to do CBT. You don't understand what? Is it order of reaction you don't understand? The one you need to understand order of reaction is it that one or which one? Is it what I've been saying since morning? So you don't understand even the temperature, even the precision, all this wise, you don't understand everything. So I need to start from the beginning. Okay. We are closing by 5 p.m. today. Let's go. We are going to start from the beginning. They see that, right? They go